Space experts have found an intriguing planet 2 times the size of Earth that might be totally covered by a sea. Adding to the fervor, this planet, known as TOI 733b, circles a star somewhat more modest than the Sun in a strikingly brief period of simply 4.9 days. That is astounding because the orbital period of the planet suggests that it lies excessively close to the star. This implies that something interesting is going on in the world that is permitting it to hold an expanse of water on its surface. The discovery of this exoplanet has addressed another well-established exoplanet mystery, the Sweep Valley Puzzle. So, how did stargazers find this far-off planet? What signs indicate the chance of a water sea on its surface? At long last, and in particular, for what reason is the discovery of this exoplanet so critical to cosmology? Since the initial location of exoplanets during the 1990s, our investigation of the universe has been persevering. We have experienced a surprising assortment of exoplanets, ranging from rocky worlds comparable in size to Earth to huge gas giants like hot Jupiters. These planets show a great many radii, with terrestrial planets normally estimating around 50% of the size of Earth and gas giants coming to up to multiple times Earth's radius. However, there is a recognizable gap between these classes. Exoplanets with radii between 1.5 and twice that of Earth are shockingly scant. It is known as the little planet size valley. Researchers have advanced different hypotheses to make sense of this shortage. One possibility suggests that mini-Neptunes, which are larger than super-Earths but smaller than gas giants, slowly shrink over time to become terrestrial planets similar in size to Earth. However, the process by which this shrinking occurs remains a mystery. This is where the discovery of TOI 733b becomes especially significant, as it offers a potential key to unwinding this mystery. TOI 733b is an exoplanet that lies around 245 light-years from Earth in the southern celestial hemisphere. It is circling TOI 733, a yellow star that contains almost 96% of the solar mass. The planet was first located in images gathered by TESS, the Transiting Exoplanet Survey satellite. So the name TOI 733 implies that it's the 733rd TESS object of interest. TESS utilizes the transit technique to search for exoplanets. When a planet passes before its host star, it causes a little dip in the star's brightness. By analyzing these changes in the starlight, the presence of a planet can be inferred. Most of the exoplanets found to date have been confirmed with the transit technique. The transit technique can also reveal some of the planet's critical physical parameters. For instance, by looking at the period at which the dip in starlight is happening, one can calculate the orbital time of the planet. TOI 733b has an orbital time of 4.9 days, which means that it circles its star very closely. At such proximity, the high-energy photons from the star can ionize the planetary atmosphere and eventually scatter it away. This phenomenon is known as photoevaporation, and it is one of the possible ways in which mini-Neptunes can contract. The radius of TOI 733b was gathered by looking at how much starlight was blocked by the transiting exoplanet. It was measured at around 1.99 Earth radii, which places it in the little planet-size valley. The next step was to work out the mass of the planet. Cosmologists utilized the HARPS spectrograph to do this. HARPS is a high-accuracy spectrograph installed on the ESO's 3.6-meter telescope in Chile. It measures the star's radial velocity to hunt for exoplanets. Furthermore, check it out, the gravitational interaction between a planet and its star makes the star move in a small circle or an oval. This movement influences the star's light spectrum, which can be observed from a distance. For a star moving towards the observer, the spectrum appears slightly blue-shifted, while for a star moving away, the spectrum is red-shifted. The spectral analysis reveals the strength of the gravitational interaction between the two celestial objects and, indirectly, the planet's mass too. The planetary mass of TOI 733b was locked at 5.72 Earth masses by performing the same measurements for the star. The data we have so far, including the planetary mass and radius, allow us to calculate the planet's density. The figures suggest a density of 3.98 grams per cubic centimeter, which is somewhat higher than that of Mars and less than Earth's 5.51 grams per cubic centimeter. Now, this is where things take an interesting turn. The discovery has opened the door to some fascinating possibilities about the planet's composition, dependent mainly upon its density. One speculation suggests that the exoplanet might have initially had a hydrogen-helium atmosphere, like Neptune's. If so, photoevaporation may have stripped away this primary atmosphere over time. This process, however, may have led to the reorganization of a secondary atmosphere, primarily composed of heavier elements. On the other hand, and more likely, the planet qualifies as a water world. Indeed, even in this scenario, the exoplanet would have lost its original hydrogen and helium atmosphere due to photoevaporation. The twist lies in the possibility of a residual atmosphere saturated with water vapor, which is significantly more resistant to photoevaporation. This scenario would mean the planet has likely retained a substantial amount of its air mass, resulting in a water world. However, determining whether TOI 733b has a secondary atmosphere or if it's a water planet is still a significant challenge. A detailed study of the planet's atmosphere is required for a conclusive answer. Now, the most reliable method for such an analysis involves comparing starlight that has passed through the planet's atmosphere with its unfiltered counterpart. But TOI 733b is certainly not an ideal candidate for such an examining workout, requiring us to wait for the next generation of telescopes to unveil the atmospheric secrets of TOI 733b. Exoplanets residing within the Size Valley, like TOI 733b, could hold the keys to unraveling the mysteries of this valley. This exoplanet, in particular, is an extraordinary subject for such investigations. It represents a small yet potentially critical piece of the exoplanet science puzzle. Therefore, future follow-up observations by high-accuracy instruments will surely provide data worth close examination. As of late, cosmologists discovered an unusual universe that produces no light. It's the first discovery of a dark galaxy in the universe. If you missed this episode, make sure to catch up on this intriguing revelation.